In this example, we're given that we're dealing with a population of trees. The mean is 110. The standard deviation is 20. So I'm just going to go ahead and write that down. We also know that we're dealing with a sample size of 100. So the first thing you're asked for is the mean of the x-bar. So this should be pretty straightforward. The mean of the x-bars is always equal to the population mean, which in this case we just said is 110. So that is part one. Don't make that harder than it is. That should be one of the easiest questions on the test. The standard deviation of x-bar is always equal to the standard deviation divided by the square root of n. So you have a little more work to do here. The standard deviation here we just said was 20. We're dealing with standard sample size of 100. So 20 over square root of 100 or 20 over 10 just gives us 2. So the mean for the sampling distribution of x-bar is 110. The standard deviation for the sampling distribution is 2. And in part 3 asks for a probability. It says the probability that x-bar, and that's important, x-bar is greater than 108. So it is important to look at this problem. It doesn't say anything about a normal distribution here. Therefore, we have to use the central limit theorem. The central limit theorem allows us to use a transformation even though we don't have a normal distribution because we have a large enough sample size. The sample size in this case is bigger than 30. So we use that same process that we've been using. This sampling distribution is going to be normal even though the general population is not. It's going to have a mean of 110, and we want the probability of being greater than 108. So 108 is going to be over here somewhere. We want the area to the right of 108. So we have to figure out the z-value. The z-value that corresponds to, keep in mind these are x-bars. We can find that by taking x-bar minus mu over sigma over square root of n. So in this case that's 108 minus 110 over, you can just use 2 because we've already figured that out. But basically it's 20 over square root of 100. So this works out to be -1. So the z-value here is -1. So finding the area greater than 108 for this distribution is the same as finding the area greater than -1 for the standard normal distribution. So remember, since we're finding the area to the right, we take 100%, or basically 1, I'm just going to use 1, minus what we get when we look this up in the table, which is 15.87% or 0.1587. So you do that subtraction and you get a probability of 0.8413. So that is your solution in this case. And it is very important that you notice that this probability is approximately correct even though we do not have a normal distribution, and it's because the sample size is large enough to allow us to use the central limit theorem. Then the last part I asked, what's the probability that x is greater than 108? And I say, what about this? I don't really want you to calculate it because you can't do it here. The reason why you can't do it is because we don't know the distribution of x. The only reason we can do it for x-bar is because of the central limit theorem. You have to know that you have a normal distribution in order to be able to do this for a single x value or for a small sample size.